Hello everyone, my dear learner, listeners, anybody who is interested in programming, in Python programming, in object-oriented programming, you are welcome. Today I am going to review object-oriented programming lessons because the course is finished. All, excuse me, all 7 lessons are done, and I want you to do a recap, review, a summary. I want you to show you one more time the coding so you can try it. And we used basically very simple classes like a case study, very simple classes, intuitive classes, rectangle, field rectangle, box. And using those classes, we demonstrated different OOP concepts, how they can be implemented in Python. And technically speaking, all those three classes, they have 3 simple methods: grow, shrink, and draw, visualize. So let me remind you today what we have done. Let me show you one more time the coding I used during the course. So let me open my Python IDLE. And what we started from was very simple class, rectangle. You see constructor, you see 2 methods. So class is basically a combination of methods and variables. So you can see in the constructor how many variables or instance variables there are. There are 3. Any rectangle has a width, a height, an outline. And constructor in Python is a special method, and what it does, it allocates RAM for your new object, initializes the variables, and then constructor going to return newly allocated object back to the main function. So always when we are talking about OOP, we are jumping back and forth. Sometimes we are at developer position, sometimes we are at the class user's position. So that's a tricky part. You always changing your perspective. Right now I'm a developer, you see my class, but if I'm a user, then I can instantiate 2 rectangles, line 3 and 4, and demonstrate how to access instance variables, how to access methods. You need object name and dot to access data, to access methods. And what happens when you call the method, the address of the object is passed to grow and it becomes self-parameter. So all the methods basically in a class are shared, but grow supposed to know which one to grow. So that's the address of the object, and it is always passed to the method. It is called self. So let's run it. Let's see what happens. And here we are. You see rectangles, two rectangles before growing, after growing, before shrinking, and after shrinking. Next step in our course, we try to add a third method to our class. It is called draw. So let me now move on to a next lesson. Let me open a next version of my rectangle class. And you see now it's more advanced. Constructor is the same, but I add draw method, and I did the drawing in 3 steps. Draw top, draw middle, draw bottom. Inside your class, if one method is calling another method, you have to still use prefix self. Be careful. So that's basically what I added to my previous version. Draw or visualizing method. And if I now change again my perspective, my position, if I'm moving from developer point of view to class user point of view, then what happens is very simple. I instantiate line 3 and I draw. Let's run it. And here we are. It's working fine. Next lesson, we explain static members. Let me open a next rectangle class with the static members. Of course, I encourage everyone to type the coding. The font is pretty big. I think it's easy to type. So what are static members? They are shared between all the instances. It's like something that belongs to everyone. So I introduced 4 static members. I wanted to make my class more reliable. I understand drawing should be done in certain limits. And I set up those limits for the rectangles from 3 to 60 width and 20 height. So lines 2, 3, 4, 5 static members. And now I can validate. When I build an object, when I call constructor, I can validate, I can sort out, check if those numbers W and H are good. If they're not good, I change them accordingly. So you see, now using static members, static variables, I implemented validation, and I implemented validation also in grow and shrink methods, because at certain point you have to stop growing, and at certain point you have to stop shrinking. Then drawing stuff is still the same. Let me by the way, open the tester So I'm testing now my static members. And you see, because now constructor is smart, it validates. You see, even I passed very weird values to my constructor. They were handled properly. I want to prove it. And you see how to access static members. You don't need any objects. You don't need any instantiations. You access static members using class name. So let's run it. And you see, yes, despite of the fact weird numbers were passed, the 3 by 3 dimensions were substituted, and you see 3 by 3 rectangles is visualized. We may have not only static variables in a class, we may have also static methods. They do not need self parameter, and you see an example. So what I did now, I added a static method. It just like explanation, so it doesn't do anything. I mean, help method doesn't do anything in particular. It just explains how to use rectangle class. So, and if I trying to use it, I see again, in order to access static methods, no objects, no instances are needed. You can call it using class name. Let's try it. And here we are. You see, help method is just a help, just an explanation, and it doesn't need any concrete objects. Good. Next lesson was about data hiding or encapsulation. Now again, let me show you new versions basically of the same class. What is encapsulation? So encapsulation is a recommendation to prevent your class users from accessing directly data members because they may damage them. Not because they are bad people, but just because of the lack of knowledge. Sometimes they don't want to do it on purpose, but they somehow damage data and class is not behaving the way it should. So encapsulation or data hiding is the idea to provide access to instance variables or data members through methods. So what I did here, I changed all my instance variables width and height to double underscore width and double underscore height. This way I hide them from my class user. However, if my user wanna read them or change them, I provide so-called getters and setters. So getter is method to read an instance variable. Setter is a method to safely I emphasize it, safely change the instance variable. You see, setWidth is validating a W parameter, and only if it's good, it's accepted. If parameter not good, it's replaced by safe values. The same I did for the height. Getter, setter. Other than that, it's still the same. So grow is the same, shrink is the same, draw is the same. The only difference, I added a prefix to my instance variables to hide them from the class user. Let's see now what happens in a test. Let me open a rectangle test, and now you see I'm using setter to set up dimensions. Setter is smart, it doesn't allow again bad values to get in. It's going to validate. I will prove it. And my attempt in line 6 to directly access width is not working. Python compiler just ignores this line. So let's prove it. Let's run it. And yes, you see, despite of the fact I tried to set width as 99, it was changed to 60, and I prove it by using getter. So I showed you in this small demo both a setter and a getter, how they can be used. The problem here is sometimes it's kind of boring for us to always use those prefixes. Also, getter also needs empty parentheses. Also, you have to type it. So there is, let's say, more advanced way to define getters and setters, and we call them properties. So let me show you a modified version of the same class. Now I changed getter and setter. I implemented them as properties. Properties basically like smart instance variables. So for me, for class developer, again, look, I'm changing my point of view, my position. So if I'm developer, properties are just methods. But if I'm a user, properties can be used just as if they are variables. So that's the beauty of the property. I don't need set, I don't need get, I don't need parentheses. So when you need to use property, you use it the same way as you use instance variables, but in fact, the methods are called and they guarantee safe access to the instance variables. So, for example, here, again, this number is not good because my property is smart. So the number going to be validated, changed to a safe value, the same here. And you don't need again get, you can just access properties as if they are instance variables. So let's run it. And yes, you see what happened is Let me show you both my tester and my console. So when I was trying to assign 99 to the width, 60 was assigned, and when I was trying to assign minus 99, again save number 3 was assigned, and then I print them just to prove. So we went through first 4 lessons coding. I just quickly reminded you what classes we used, and the next video, so I'm trying to keep my videos shorter. So next video I'm going to again quickly review the coding for lesson 5, composition, 6, inheritance, and polymorphism. So we are going to do one more video reviewing one more time our case study, our classes, our coding. I encourage everyone to try what you see, and as usual, I appreciate your subscriptions, your comments, and your likes. All the best, and wait for my final video on Python OOP. Take care.